chance to finish the last time. So I just wanted to show you the sort of things, you know, now that we finished the section, the sort of way in which this gets questioned in your exams and in your final exam. So all of the questions that I have got here tonight, except for the ones that are a little bit down below, but I'll show you those later on. These are all from NSC papers. So this is exactly the sort of thing that they would expect you to be able to do. And you can see some years the questions are fairly easy, and then other years the questions are a little bit more difficult. But there's a couple of things here that I wanted to discuss with you. As far as 8.2.1 is concerned, that really is just a straightforward question. There are no tricks there or anything like that. You can see in 8.2.2, that's just a little bit more difficult. Are you guys happy to do 8.2.1 and 8.2.2? We have use that as a warm-up, and then we can go on to the next one. Okay, all right. Cool, Michelle. Thank you. And of course, when you're finished, you can just say done in the chat or whatever. Okay, lovely. Thank you, Lorato. Thanks, Michelle. Hi, Tato. Okay, so for anybody that's just joined us, we're doing 8.2.1 and 8.2.2 is warm-up. You guys are going to do this, and then I'm going to go through it afterwards with you, and then we're going to move on to some other questions, okay? Any questions, just shout. Okay, thank you. Wow, Thelma, amazing, good. Cool, Lorato, well done. I'm just going to wait another minute or so. Thank you, Taniko. Good job. And Morongo, nice, well done. Okay, and Oratile, you're also done. Okay, I think that's most people then. All right, so in 8.2.1, all we need to do is get rid of the divide line over here and get that x squared into the numerator. So f of x equals x squared minus 3 plus 9x to the power of negative 2. And now we're ready to differentiate. So we're going to write f prime x equals 2x. The minus 3 is going to become 0. And then here we'd end up with minus 18x to the power of negative 3. Okay, so I don't know if I've got the memo for this one off on the side. I've got some of them. What's this one? What's there? That's so difficult to see. Oh no, I don't think that's the right one. Okay, but the 3 marks that it's out of would have to be for the negative 2, writing the x to the negative 2, a mark there and a mark there. Okay, matrix. And then 8.2.2, remember we have to get rid of brackets, divide lines, and radicals. Okay, so g of x is equal to, so root x times root x is going to be x. Then it's going to be minus root x plus 3 root x minus 3 when the brackets are gone. All right, so what I'm going to do now is I'm going to get rid of my radicals. So minus x to the power of 1 over 2 plus 3x to the power of 1 over 2 minus 3. And I guess these two are like terms, aren't they, in the middle? So we can combine them into one term. So that gives us x plus 2x to the 1 over 2 minus 3. Okay, so therefore g prime x is equal to 1 plus, and then a half times 2 would also be 1, x, and then take 1 away, that would be minus 1 over 2, and then the minus 1 would become 0. Okay, is everybody happy with that? Did you get the same answer? Oh, good job. Okay, so there definitely has to be a mark on that, I imagine there has to be a mark on that as well, and then there must be some other kind of mark for removing the brackets as well. Okay, so those ones really were not that difficult. Hopefully that'll be 7 accessible, nice marks for you at the end of the year. Cool beans. All right, now let's go on and have a look at this. Now, I know that you can do question 7.2 very easily. All right, we've warmed up already, so I don't think that there's any need for us to do 7.2 unless you particularly want to. But this is what I was trying to explain to you the other day when we were talking about only being able to differentiate with respect to one variable at a time. So the 2019 paper, this is now prior to COVID, was particularly difficult. And that's where these particular questions come from. Sorry, Bochepo, you've got a question about 8.22. Where did I lose you?
Ma'am, when negative 3 became negative 1.
Absolutely. Why is it negative 1? Okay, sorry, Bochepo, you're quite right. That should be a 3. Perfect. Sorry. Thank you very much. Quite right. It should be a negative 3, not a negative 1. Okay. So back to this question from 2019. This is what I was trying to talk to you about when I was saying that when they expect you to be able to differentiate with respect to one variable at a time. So in question 7.3.1, they ask you to differentiate y with respect to x. And then in question 7.3.2, they also want you to differentiate y, but with respect to a. So that's why I wanted you to see that question earlier in this course, because it can be asked at the end of the year. And then the other reason why I want to do this question is because of question 7.4. Okay, so I think what I'm going to do is this. I'm going to let you do 731 and 732 by yourselves, and then I'm going to do 7.4 with you. If you do finish 731 and 732 very quickly, you're welcome to get started on 7.4, but I will mark the others before I start on that. Okay, and of course, if you've got any questions, please ask Nicole and I. Cool, Orotile, well done. You can start looking at question 7.4 in the meantime. Nice, boy, Shepo, lovely. Okay, so Tisha, some people are late and then they just say, I'm sorry that they've come in late. I suppose like you would say if you were sorry if you walk late into class, but it's really not a big deal. Okay. Cool, Lorotto, lovely.
I think Atisha wants to know, Lee, what do they mean with DA in 7.3.2?
Oh, okay. Sorry, I misunderstood you completely. Okay, so Tisha, In 7.3.2, they want you to differentiate y with respect to a, not y with respect to x. Remember, you can only differentiate with respect to one variable at a time. So you are treating a like the x in this question, and x becomes your constant. But I'm gonna show you right now, Tisha. I'm gonna do that with you, and then we're gonna do 7.4. Okay, Neo's done. There's a few of you that are done on a T there. Okay. I'll just wait one more minute. And then we'll do 7.3.1 and 7.3.2. And then we're going to do 7.4 together. Oh, wow. Oratila, you're done with 7.4 as well. I'm super impressed. You're going to have to tell me what the answer is, Oratila, before I do it. Okay. Nice, Moronkoa. Nice, Aisha. Okay, so let's just whiz through those. So in 7.3.1, I'll tell you what, instead of me saying this is the answer all the time, let me ask you guys, does somebody want to tell me what they got for 7.3.1? Can either unmute or put it in the chat. Anybody feeling? Neo, do you want to share an answer? Okay, Aisha. All right, so Aisha says minus 2x plus 1. Why minus 2x?
Oh, hi, ma'am. So
Hi, Aisha.
Hi.
Is
So
that for 7.4? Is that your answer?
No, 7.3.1.
Oh, okay. So your final answer for 7.3.1 was y equals, no, sorry, the derivative is minus 2x plus 1.
Yeah.
Why is it, okay, why is it minus?
Because it was y minus x squared. So then, you know, I basically differentiated that and became 2x minus 2x, and then the y became the plus 1. So I don't know.
I don't know if we're not talking about the same question, Aisha. Are we talking about 7.3.1?
Yes, ma'am.
Okay, so in 7.3.1, they give you y equals ax squared plus a. And then they want you to find the derivative of y with respect to x. So here, what you would have done is you would have said dy over dx, and you would have said 2 times a being the coefficient of x squared would have given you 2a. Then you would have had to subtract 1 from the x, so that would have been x like that. And then as far as your, let's move this, you're not differentiating with respect to a, you're differentiating with respect to x. Okay, so can you see your a would have become 0, so it would have just been y, dy over dx equals 2ax. So this would have been plus 0. Okay, so therefore dy over dx would just be 2ax, like so. Okay, matrix. Then in 7.3.2, they want you to differentiate y with respect to a. If you want to, what you could do is you could reorder it. I mean, it's not necessary for you to do that, but you can write the x squared in front of the a, plus a like that. And now when you do dy over dA, you're going to derive. So you're going to say the invisible 1 times x squared is x squared. Then you're going to take 1 away from the a. Okay, so 1 away from the exponent of a. So that's why it would become a to the power of 0, which is 1 times x squared plus 1. Okay, 1 times the coefficient of 1, and then taking 1 away from the exponent. Okay, so that's why this one would be out of 2. This was out of 1 because it's 1 mark on the answer. This one's out of 2, 1 mark for the first term, 1 mark for the second term. Okay, matrix, everybody happy with that? All right, cool beans. Now, Orotile, you say that you already did 7.4. Why is it plus 1? Okay, Cassandra, because you are, so in other words, Cassandra, if we had y equals x squared plus x, right? And now I'm finding the derivative of y with respect to x. I would end up with 2x plus 1, wouldn't I? Because you'd say 1 times the 1 in front, and then you're going to end up taking 1 away, all right? So then it's going to be 1 times x to the power of 0, which would just be 1. It's the same story with this. Okay, so you're differentiating y with respect to a, not with respect to x. So that's why it has to be plus 1. Okay, does that make sense? Okay, so it's like the a is the x in 7.3.2. Okay. Alrighty, so let's get rid of that. Now, question 7.4. Orotile, I'm interested to know what your answer is. What did you get as the equation of the line perpendicular to the tangent of the curve at A? Do you want to share your answer? Or did you share your answer? Oh, you did share your answer. Okay, so Orotile said the answer is y equals 1 over 2x plus 7. Okay, now I think the answers are here on the side. Not I think, I know I put them there earlier. Let's just have a look and see. You are such a clever girl. Hey, that's amazing, Orotile. Look at that, you got the right answer. Okay, so I'm just going to quickly hide that so that the others can't see. That's lovely, Orotile. Well done. That's supposed to be like not very difficult, but it is certainly a difficult question. Okay. In that case, Orotile, I tell you what, so difficult to try and have enough space on here for everything. Okay. Right, Orotile, the next question that I want to do, or anybody else that was able to do that, is this one over here. Okay, so this 8.2.2 was sort of the next difficult one that I wanted to do with you. I'll try and make it a bit bigger, and then I'm just going to do 7.4 with everybody else. Okay, all right, everyone, let's pull that down here. Orotile got that right. That was so lovely. Good job. Okay, so they've given us a curve, and they've told us that the equation of the curve is y equals x plus 12 over x. And they tell us that it passes through a point A, and they've given us the x coordinate at that point 2, and they've called the y coordinate at that point B. And they've asked us to determine the equation of the line perpendicular to the tangent to the curve at A. All right. So if we want to work out the equation of the line that is perpendicular, essentially what they're asking us to do is they're asking us to work out y equals mx plus c. That's what they want from us, okay, the equation of the line, all right? Before we can, well, in order to be able to work out the equation of the line, there are two things that we always need, okay? We need to know the gradient, and we need to know the y-intercept. The process is always, all right, use the derivative to calculate gradient. In this case, there's something else that we're going to have to do because they're talking about a gradient that's perpendicular. X and y have to be the x and y coordinate the point where it goes through. And then C we calculate as a variable. So once we know M and we know X and we know Y, we can sub into Y equals MX plus C, and then we can solve for C. That's our usual process, all right? What have they given us here? They've given us X. So if they've given us X, it means that we can get Y or B. All right, so that would be our first step. So Y equals X plus 12 over X. Can you see they've told us X is equal to 2 and Y is equal to B? So that would be 2 plus 12 over 2. So that means it would be equal to 8. So that means we have got the coordinates at A. We've got 2 and we've got 8. Right? Now what we need to do is we need to find the gradient at that point. All right, so how are we going to find the gradient at a point? We're going to use the derivative. Okay, so in other words, the gradient of the tangent, okay, is going to be equal to the derivative of y with respect to x. Does that make sense to everybody? So I'm going to derive, so dy over dx, and that would leave me with 1 plus 12x to the power of -2. Does that make sense to everybody? Right. Now, if I want to work out what the gradient is at point A, I need to sub in 2. Right, so I can work out the gradient of the tangent by subbing 1 plus 12 times 2 to the power of -2. I can do it like that. Or if you wanted to, you could take it into the denominator and make it positive, completely up to you. It's not going to make any difference. So that would be 12 over 2, and then that would have to be squared. Okay, so that's going to be 12 divided by 4, so that's going to give us a gradient of 3 plus 1 is 4. No, hang on a second. No problem, can you see, Lee? The denominator to make it positive. Sorry, I thought I've made a mistake here. I don't know if I have. Let me just double check my work. That would be 1. Oh, that's my mistake. Okay, all right. Here, you see, this is why it never pays to take shortcuts. Sorry, my mistake is with my sign. I beg your pardon. Okay, so let's first of all write it as y equals x plus 12x to the -1. There's my mistake over there because I wrote plus instead of minus. So dy over dx is equal to 1 minus 12x to the power of -2. Okay, so that's going to give us 1 minus 12 over x squared. And therefore the gradient of the tangent is going to be 1 minus 12 over 2 squared. Okay, so that's going to give us an answer of -2. Okay, so the gradient of the tangent is -2. The gradient of the line that is perpendicular to the tangent, remember, the gradient of the tangent times the gradient of the perpendicular gives us -1. So if the gradient of the tangent is -2, the gradient of the perpendicular will have to be 1 over 2. All right, so we've now essentially got this value of m here which has got to go in there. All right, so, and then as I was saying to you at the beginning, subbing into y equals mx plus c, we've got the x and the y from point A, we've got the gradient, and then we can work out what the value of c is. Okay, so subbing into y equals 1 over 2x plus c, that means that 8 equals half of 2 plus c, and obviously half of 2 is 1. So that would be 7. Okay, so c would be equal to 7. So that's why it has to be y equals 1/2 x plus 7. Does that make sense to everybody?
Yes, ma'am.
Okay, good stuff. Everybody happy with that? What do you think, Matrix? Do you think it was a difficult question? Or do you think it was quite an easy question? I mean, if I hadn't showed you how to do that, would you have known how to do it by yourselves? Okay, cool. All right, that's awesome. All right, good job. Okay, so as I was saying to, okay, well, that's fine, Thelma. That's why we've done it together. Okay, hopefully it makes sense. Okay, are there any questions before we carry on and talk about 8.22? Everybody happy? Okie dokes. All right, so again, I don't want us to do 8.2.1. We've got past that point by now. This is what, let me just get rid of myself, what I was asking Oratile to do while we were busy. Now, we gave our boys a question like this in our control test before they wrote exams, and it was surprisingly how few of them actually got it right. So that's why I wanted to do this with you as well. I'm talking specifically about 8.2.2 metrics. Anybody got an idea as to what we're supposed to do? How do we find the derivative of y with respect to x in 8.22? Any ideas on what we need to do first? No ideas? Oratile is done with both. Okay. Just responding to someone. Okay, so you cannot find the derivative of y if y is not the subject of the formula. Okay, so you have to make y the subject of the formula if you want to find the derivative of y. There we go. Take the yx over and divide by. You're on the right track, Tato. Neo, take out the common factors. Absolutely. Okay, so what is the common factor on the left-hand side? So here, on this left-hand side over here, the common factor is? Indeed, Neo, quite right. Okay, so that's what we're going to do. We're going to take y out as a highest common factor. All right, and then that will give us in brackets x minus 1 equals 2x squared minus 2x. All right, and now to make y the subject of the formula, we have to divide both sides by the bracket. Okay, so now y is the subject of the formula, and we've been given 2x squared minus 2x, and we will divide that by x minus 1. And now you proceed as normal for what you would do if you had a binomial denominator. Okay, so remember, if you've got a binomial denominator, the next step is to factorize. Okay, so we will leave it as y equals. At the top, we can take out 2x. That leaves us with x minus 1 over x minus 1. What is that and why is it there? And now that can cancel. So if y is equal to 2x, then it means that the derivative of y with respect to x in this case is 2. Okay. And that's why they placed that restriction on x up here. I'll just get it in a different color. Okay, and they said, well, x cannot be equal to 1. All right, not that that changes anything, it doesn't, but this is why, because otherwise then we would have a 0 denominator. That's why they told us that. Okay, so that's a really nice question that I wanted to do with you as well. Yeah, how do you feel about that one? Cool. Yeah, it's funny. It's funny how, like, at the beginning we sort of like look at something and think, but how on earth are we going to do this? And then after we've worked through it, it's like, oh, well, that's so obvious. Yeah, that's why I'm trying to do these questions with you, Cassandra. I especially went and found ones that I know come up, and the sort of little tricks that they like to give you. Okay, that's why I'm doing these on purpose. Yeah, they are. You're quite right, Aisha. They're actually much easier than you seem. And can you see how they are never asking us anything outside of what we know? We just have to apply what we know. So yeah, just try and remember that when you see a question. They're not asking you to apply something that you don't know. It's something that you would have come across somewhere in the syllabus, or hopefully hear it at Watobe with me as well, because I'm going to try and expose you, or I have been trying to expose you to as many different things as I possibly can, and I will continue to do so until you finish writing exams. Okay, and then this last one over here is not particularly exciting. I can't remember which past paper this was out of, but there really is nothing much to see here. I chose this question because it had a pi in it. So I thought we could just talk about what would happen there. 7.2.1 is super simple. Just remove the brackets by FOIL and then derive. Just be careful. Don't drop your dx in your square brackets until you're ready to derive. Okay, you don't want to lose even 1 mark because you were penalized for incorrect notation. All right, so is pi a variable or is pi a number? Is it a...
It is a number.
It is a number, quite right, Morongo. It is a number. So essentially, what's going to happen to that last term? It's going to become?
Constant.
Well, it is a constant, that's right. So when we derive it, it would become?
0.
That's it, exactly. Okay. All right, I don't think we need to do 7.2.2, do you guys? Can we move on? Unless you particularly want to. We can move on. Okay, all right. Now, I think what I need to do is actually go and find questions that are even more difficult. I'm just worried that these things that I'm going to do now are going to be a little bit too easy for you. But anyway, let's give it a bash. All right, so if you had a question like this where it said to you, find the point on the graph of y equals x squared minus 5x minus 1 for which the gradient is -2. How would you approach this problem? What would you do? No, Kanyisile, you don't have to change pi into numbers. If you want, I can just quickly do the question with you and to show you what would happen. Sure, okay. Let's leave that one there. All right, so those of you that are feeling super confident, if you want to think about this question here about finding the point on the graph which the gradient is -2. I'm just going to quickly do this. Okay, so we've got y equals x to the power of 3/2 minus 5x to the power of -1 plus 1/2 pi. Okay, so now we're ready to derive, can you see there? So the derivative of y with respect to x will give us 3/2x, take 1 away, so that will be 1/2, plus 5x to the power of -2. And then this term here, can you see there, would become 0 because it's a constant. Okay, and that would be your answer. If I haven't made any mistakes, which I don't think I have. Okay, all good. All right, there we go, no problem. Pleasure, Kanisile. You happy with that, Michelle? Making sense? I know. Yeah, they can do, can't they? But that's why I'm glad we did it. Because that is what they're trying to do. Well, they're not trying to throw you off, but they're trying to test, yes, do you understand that pi is just a number? Okay, all right, so let's go back to this question. So if they ask us to find the point on the graph for which the gradient is -2, it's a greatest pleasure, Aisha. There is a very interesting relationship between gradient, input, and output. I don't know why, but just over the years that I've been teaching matric maths, this is how I always set it out. And I don't know if it's necessarily the best way, but this is just how it makes sense to me. And X, your input, okay? So in other words, that particular point that we're talking about where the gradient is -2, the particular X coordinate at that point, X is like the link in the middle. All right, so in other words, if you get given X, you can work out what Y is, just like we did over here. Okay, so in this question up here in 7.4, they told us what X was. So we subbed X in and we worked out what Y is. So if they give us X, we can work out Y. If we've got X, we can also get the gradient, just like we did here. We took the derivative, we subbed in whatever X was over here, and that gave us the derivative or the gradient. So X is the key in the middle. X is the thing that connects M and Y together, all right? So if they give you a question where they're giving you the gradient, like they are with this one, okay, they're telling us that the gradient is -2. You first have to work out the X coordinate and then the Y coordinate. Okay, so X is the one in the middle. If they give you M, you've got to work out X first, and from X, you can then go and get Y. All right, so that's what this question is asking for. When it says find the point, they are implying calculate the X and the Y at the point where the gradient is equal to -2. The other thing that you've got to remember is what is that? What is y equals x squared minus 5x minus 1? It is a what sort of function? We've been doing them since grade 11. It's a parabola, isn't it? Okay, so it's a smiley face parabola. Exactly. All right, exactly. It's a quadratic function. So where is the gradient negative? Okay, so it's going to be any point before your turning point. Okay, so I don't know if the gradient here is -2 or there or there or there or there, but somewhere to the left of the turning point, that's where your gradient is going to be negative. After your turning point, the gradient is then going to be positive. So this point is located somewhere on the left of the turning point. I'm just putting it into perspective for you. You don't really need to know that, but I think when you do understand what you're doing, it makes things a lot easier. Oh, oopsie, sorry, wrong thing. Okay, let's get rid of that. Okay, so they've given us the gradient is -2. They give us the gradient. The first thing that we have to work out is x, all right? So now, how are we going to link what we see here to our gradient? Remember, our gradient is our derivative, our gradient at a point. So here, we need to derive y with respect to x. So that will give us 2x minus 5. And dy over dx is the gradient, isn't it? Okay, so I'm going to write that for you. I think you guys know that anyway. Dy over dx is the gradient at a point. So that means we can sub -2 in place of dy over dx. And we can solve for x. Okay, so I'm going to take the 5 over to the other side. That's going to leave me with 3. And dividing both sides by 2, x is equal to 3 over 2. Yes, cool. Can you see that I get the same answer? Okay, and now that we know what x is, we can then go and work out what y is. So y is going to be equal to 3 over 2 squared minus 5 times 3 over 2 minus 1, whatever that is. Exactly. All right, so you're going to substitute the x in so that you can get your corresponding output. Absolutely. I don't have a calculator with me. It wasn't very well organized. I could work this out in my head. Can someone work this out for us, please? What would you get if you had 3 over 2 squared minus 5 times 3 over 2 minus 1, please? Okay, cool. So Taniko and Neo say -25 over 4. Thanks, guys. That just makes life a bit easier. -25 over 4. All right, cool, Nicole. Thank you so much. Okay, so the point that they are asking us to calculate, it's the point 3 over 2 and -25 over 4. Okay, well done, everybody. Lovely. Okay, so I don't know what you think of this silly little drawing of mine with the m and the x and the y, but I think it really helps. Okay, so again here, determine the equation of the tangent. Now this is a little bit different because they're asking you for the equation of the tangent. 2f of x equals x squared minus 6x plus 5 at x equals 2. Okay, so here again, they're giving you the 2. You can choose. Do you want to work out the gradient first, or do you want to work out the corresponding y coordinate first? I want to let you try this on your own, and then we can go through it together. That's fine, Cassandra. If that's what you want to do, go for it. Okay, so I'm going to give you guys, well, you tell me when you finish. Put down into the chat when you're ready, and then we can work through it together. Wow, Taniko, that's amazing. What I'm going to do then, Taniko, is I'm going to pull the other question up that I wanted you to try before you go, and then at least you can start working on that one. Lovely, Thelma. Good job. Okay, look at the next one, okay? We'll see if we can do both of these before you guys go tonight. Lovely, Valerie. Well done. Okay, go on and look at the next question. Nice, Neo. Lovely, cool. Nice, Kanisile. All right, so I'm just going to slowly start working through this question. The people that are finished with this, Neo, Kanisile, who else told me you were done? Hold on a second. Moronghoa, Valerie, Thelma, Taniko. Go on and look at the next question, okay? Paul, good stuff, well done. Good job. Okay, so for the equation of the tangent to f of x equals x squared minus 6x plus 5 at x equals 2, I got the equation of the tangent to be y equals minus 2x plus 1. Do you agree, Matrix? You get the same answer?
Yes, ma'am.
Lovely, Moronkoa. Okay, so with this question here, hopefully, sorry, and the reason I'm starting this is because our time is running out. What are you going to make x squared plus 4x minus 5 equal to?
-8.
Oh, you see, you guys are too clever. You don't even need me anymore. Well done. All right, and now you're going to solve for x. Okay, so add 8, that would give us plus 3, wouldn't it? And then when we factorize this, we would have x plus 1 times x plus 3 equals 0. So now we've got two solutions for x. Either x is equal to -1 or x is equal to -3. But they've told us if the gradient of the tangent is negative. So we've now got two different points. We've got one point where it's -1 and -8. And then we've got another point where it's -3 and -8. Okay, so now the gradient of the tangent needs to be negative. Okay, so that means that m needs to be negative. So let's take our derivative, okay, and then we can test to see which one of these x values gives us a negative, or maybe they both do, and then we have to accept two answers. Okay, so g prime x is 2x plus 4. Okay, so now when we sub in g prime -1, we're going to end up with 2 times -1 plus 4. So that's going to give us -2 plus 4, which gives us +2. Okay, so therefore the x coordinate at the point for this, it cannot be -1. Okay, because here the gradient is positive. Okay, can you see we've ended up with a positive answer? Let's go and test the other one now. Go and sub it in. So, woo, whoopsie daisy. G prime -3 into our derivative. So that gives us 2 times -3 plus 4. So that's -6 plus 4, which gives us -2. Okay, so this is the x and the y and the m, the gradient, that we have to use. Okay, matrix, does that make sense to everybody? So subbing into y equals mx plus c, y equals mx plus c, we have -8 equals -2 times -3 plus c. So that means that would be my +6 minus 6 minus 6 would be -14. And if I'm not mistaken, I would say that it's y equals -2x minus 14 is the equation of the tangent. Does that make sense to everyone? How does that feel? Okay, where did I lose you? Cool, everybody. It is time for the quiz now. If you want to go and do the quiz, you're more than welcome. Cassandra, what can I repeat for you? What did you not understand? Cool, Nia, I'm glad it was great. Okay, so Cassandra, where were you stuck? The last part. Okay, so when you say the last part, you mean the bit in orange? Where I drew the circle? Yes, okay. So what I was doing here, Cassandra, is I was working out which point, whether it's going to be this point over here or that point over there, that has a tangent that is going to be with a negative gradient, okay? So what I was doing is I was subbing my x, okay, my -1 into my derivative, okay, so into my derivative from here. to work out what the gradient of the tangent is going to be at x equals -1. So as it turns out, at x equals -1, the gradient of the tangent is positive. It's +2. All right, that's not what I want. I want the gradient of the tangent that is negative. Okay, so that's why I'm saying I'm actually disregarding this answer. Okay, so this does not happen where x is equal to -1. It only happens where x is equal to -3. Okay, so I did the same thing here where I took my x coordinate, I subbed it into my derivative to work out the gradient of the tangent at that point, which was -2. Okay, and now I have my x, my y, and my gradient. So here I can sub into y equals mx plus c. There's my y coordinate, there's my gradient from here, and there's my x coordinate. Okay, and then I could work out what the value of c is. Does that make sense? Okay, no problem, Cassandra. Is there anybody else who's got a question? Okay, well, in that case, you are more than welcome to log off and go and do the quiz. And I shall see you guys on Tuesday. All right, so we're going to start our winter school, and I'm going to do some functions with you because I think that that's something that we probably need practice from grade 11. So I've got some nice difficult questions in there as well that we can go through. All right, everybody, take care. Have a nice weekend. Bye, everyone.